In geometry, a triangular prism is a three-sided prism. It is a polyhedron made of a triangular base, a translated copy, and three faces joining corresponding sides. A right triangular prism has rectangular sides, otherwise it is oblique. A uniform tagular prism is a right triangular prism with equilateral bases, and square sides. Equivalently, it is a pentahedron of which two faces are parallel, while the surface normals of the other three are in the same plane. These three faces are parallelograms. All cross-sections parallel to the base faces of the same triangle. As a semi-regular polyhedron, a right triangular prism is semi-regular or, more generally, a uniform polyhedron if the base faces are equilateral triangles, and the other three faces are squares. It can be seen as a truncated trigonal hosohedron, represented by Sacurrency Flea symbol T2, 3. Alternately, it can be seen as the Cartesian product of a triangle and a line segment, and represented by the product 3x. The dual of a triangular prism is a triangular bipyramid. The symmetry group of a right three-sided prism with triangular base is D3H of order 12. The rotation group is D3 of order 6. The symmetry group does not contain inversion. Volume: the volume of any prism is the product of the area of the base and the distance between the two bases. In this case the base is a triangle, so we simply need to compute the area of the triangle and multiply this by the length of the prism, where b is the triangle base length, h is the triangle height, and l is the length between the triangles. Truncated triangular prism: a truncated right triangular prism has one triangular face truncated at an oblique angle. Facetings: there are two full D2H symmetry facetings of a triangular prism, both with 6 isosceles triangle faces, one keeping the original top and bottom triangles, and one the original squares. Two lower C3V symmetry faceting have one base triangle, 3 lateral crossed square faces, and 3 isosceles triangle lateral faces. Related polyhedra and tilings. Symmetry mutations equals: this polyhedron is topologically related as a part of sequence of uniform truncated polyhedra with vertex configurations, and n3 coxeter group symmetry. This polyhedron is topologically related as a part of sequence of cantillated polyhedra with vertex figure, and continues as tilings of the hyperbolic plane. These vertex transitive figures have reflectional symmetry. This polyhedron is topologically related as a part of sequence of cantillated polyhedra with vertex figure, and continues as tilings of the hyperbolic plane. These vertex transitive figures have reflectional symmetry. Compounds equals: there are 4 uniform compounds of triangular prisms, compound of 4 triangular prisms, compound of 8 triangular prisms, compound of 10 triangular prisms, compound of 20 triangular prisms. Honeycombs equals: there are 9 uniform honeycombs that include triangular prism cells, gyro-elongated alternated cubic honeycomb, elongated alternated cubic honeycomb, gyrated triangular prismatic honeycomb, snub square prismatic honeycomb, triangular prismatic honeycomb, triangular hexagonal prismatic honeycomb, truncated hexagonal prismatic honeycomb, rhombitriangular hexagonal prismatic honeycomb, snub triangular hexagonal prismatic honeycomb, elongated triangular prismatic honeycomb. Related polytopes equals: the triangular prism is first in a dimensional series of semi-regular polytopes. Each progressive uniform polytope is constructed vertex figure of the previous polytope. Thorold-Gossett identified this series in 1900 as containing all regular polytope facets, containing all simplexes and orthoplexes. In Coxeter's notation, the triangular prism is given the symbol A121. 4-dimensional space equals: the triangular prism exists as cells of a number of 4-dimensional uniform 4 polytopes, including. See also, wedge. References: Weierstein, Eric W., Triangular Prism, MathWorld. Interactive polyhedron, triangular prism, surface area and volume of a triangular prism.